to today's SANS webcast, Is Your API Exposed? Sponsored by Traceable. My name is Mary Langolier of SANS. Today's featured speakers are Dave Shackleford, SANS analyst, and Dan Gordon, Traceable technical evangelist. If during the webcast you have any questions for our presenters, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Fantastic, and thanks so much for that intro. Thanks everybody for joining us today. Super excited to be here and joined by Dan Gordon. And really, these are fun. These are the fun webcasts where we get to talk shop, and in particular, talk shop about a product that we had the opportunity to review. So I'll get to that here in just a moment. But this particular topic is near and dear to my heart, especially right now. And I think the title probably says it all. Are your APIs exposed? That is actually a question that a lot of organizations can't adequately answer right now. And some of you out there today may be thinking to yourself, yep, that's us, right? But some of you may be saying, hey, maybe we have a little bit of an idea, but you don't necessarily know A, how exposed they are, or B, where there are potential vulnerabilities or avenues of exploitation or exposure that could lead to definitive threat, sort of threat actors taking advantage of us, having their way with us in a variety of different scenarios. So again, very excited to be here and to talk with Dan and really speak with all of you about the Traceable platform. So, the whole idea here is, and Dan will elaborate at a variety of inflection points throughout this because he's got a lot to say about it as well. But having worked with a lot of DevOps teams, worked with dev teams, worked with DevOps teams, and we'll bring a little bit of cloud flavor into it just because that's a factor. Things like the CI/CD pipeline in many cases are doing significant deployments out in the cloud. I sort of jokingly say, everything's a web app today or a web service today. And I'm only half kidding. And I think you probably all know exactly what I mean. And I think cloud has driven a lot of that, although not necessarily in its entirety, right? Just the way that we're doing development and deployments today has necessarily sort of webized everything. But also what we found is that APIs and the exposure of those APIs is critical to the way that modern application infrastructure operates. You know this, I know this, we know this, but dun dun, there's a dark side to it, right? Which means attackers are very well aware of the fact that we've got these APIs sort of all over the place. And in many cases, we're moving faster than ever. And so naturally, for any of you in DevOps organizations or that work with DevOps teams, you know this, the nature of how DevOps is working is speed. It's accelerated deployment, accelerated development practices. Sort of jokingly, I call this agile on steroids. But what that can unfortunately lead to are some risks due to that velocity and sometimes just not having the visibility that we need. So the exciting thing that we get to talk about here is our Traceable review. So the Traceable AI platform, basically, and again, Dan will give some good context on this, can do all of the various things you would want with regard to API security. And I know that's a broad statement and a big one, but what we're hoping to do throughout the course of this webcast is really demonstrate that to you and show you some of the different features and facets of what Traceable brings to the table. It can show you which APIs are in use. They can help you map out application flows across services, and all of those APIs, going to a significant level of depth, can demonstrate where sensitive data is noted with those APIs and how they're being used. And maybe last but not least, of course, profile risks and the types of attacks that these APIs are potentially exposing. And so the team at Traceable basically set us up, provisioned an account for us, set us up with sort of a cloud-based online store, which was perfectly good, right? It was exactly the right amount, had some pretty interesting APIs, definitely lots of web services that were there and sort of plugging things together. And what we found when we logged into the platform is, and I always start with this, and I think it's critical, especially for security teams or DevOps teams or both that are going to be working with a solution like this, it needs to be easy to figure out. And it, number one, wasn't cluttered. Certainly logging into things for the first time, what you want to find is an intuitive interface with menu systems and labeled categorical areas that you sort of naturally know what you're getting into. That's huge. So I didn't have to fumble around and figure things out. In fact, the team at Traceable provided me with all sorts of sort of walkthroughs and examples of sort of flows and things that you would want to do, which is exactly what we were hoping for. But I found that in many of the cases, I really didn't need them because they make it really easy to figure out where you're going, what you're looking for, and sort of how to plug all this stuff in. So there's a bunch of different sections in here. Some things focused on API discovery, of course. That's got us, we have to start with discovery so that we know what we're looking at. We have monitoring capabilities. We have some protection tools and services as well, which we'll be talking about here in just a bit. And then incident response and forensics. And so just before we move on, what I want to highlight is that there's a lot of use cases built into this tool or into this platform for a number of different constituents in any organization. This isn't just a security platform. It's certainly not just oriented towards developers or infrastructure or cloud engineering teams. I'd argue any and all could easily find themselves in this platform looking at things that, number one, make sense to them, and two, inform them in a variety of ways as to what the security posture of your API infrastructure looks like. So with that, I'm going to jump in and just start off with the very beginning, this API catalog section. The API catalog, as labeled, is essentially the cumulative discovery of the APIs that are in the environment. And as they're discovered, so this is kind of the cool thing, there's really very little delay to the whole thing, right? There's a discovery process that's ongoing in a continuous fashion. So in other words, Traceable's constantly sort of scouring and looking at interactions and things talking to each other and where those exposure points might be. But the risk evaluation is done right along with that. That's done in tandem, in parallel with that discovery. So it's not as though you do discovery first and then hang out for X amount of time and wait for all the risk analysis to be performed. We actually found that it was happening simultaneously. This was sort of populating within the context of the console sort of at the same time. So it's continuously updating with all of these different endpoints that are seen, external API calls, internal API calls, and then of course the traces, which we'll get to here in just a second, looking at those queries. So it's not just the APIs, but it's also the sort of depth of query, which is things like your headers, timestamps, things that are probably valuable, I would say, for, again, a lot of reasons. Troubleshooting, number one. If I'm trying to figure out why something's maybe not working within my application infrastructure, I'm going to want to trace it through, right? I'm going to want to look and see, hey, where's it coming from? Is something getting blocked? Are we getting a weird response, right? I want to get down into the guts of it. But as a security professional trying to figure out, hey, am I being attacked? Is this just a weird query that's coming in from, a client of mine or a customer or something? Or does it look like some sort of an attack that might be taking place either slowly or, sort of rapid fire? I can get all that. So there's a lot of detail within the console. And, I've got a whole bunch of screenshots and things in here. And I know Dan's got several that he's going to be bringing up and talking to as well. But this doesn't even begin to show you the depth of information that's present here, right? So it's always fun taking screenshots and having to speak to them and say, look at this amazing screenshot. But there's a lot of things within this one dashboard right there at the top of the list in API activity that you can dig down into. So we can see live requests. You can see sort of the top list of API endpoints that have been observed sort of cumulatively over the period of time that monitoring has been going on. You've got the total number of calls. You've got the geographic locations related to all this, which I think is kind of cool, especially if you're looking at maybe an attack campaign or a specific actor that is known to operate from a geographic region. This is stuff that can help you build out your own threat intel and tie it together with known information from, say, the community or from some other sort of threat intel sharing source. So right there, that one snapshot automatically starts getting you some sense of, hey, there's a lot of visibility here within this platform, right? And I can get to that extremely fast, didn't have to do a lot of digging whatsoever. So the second thing, of course, kind of moving through this catalog, as it's building the catalog, as we're building out these application flows, is, hey, it's mapping this all together. So this application is comprised of these various types of services. Here's the APIs that have been observed. Here's what they look like. Here's how often they're being observed. Here's information about those. And this, to me, was where really the platform started to shine. because I just immediately saw where the usefulness of this platform for so many different types of constituents and stakeholders within an organization would immediately flourish, right? You're going to see the entry point. You're going to see, where that entry point went. You're going to be able to trace that to any sort of backend services. So you've got all your varied tiers or components related to your application architecture sort of right there in front of you. But even more so, you're also seeing firsthand where there's potential, sort of risks that are showing up. You're seeing the volume of these. So particularly if somebody's trying to execute, maybe a denial of service attack, or they're doing some sort of like a brute forcing attempt against one of your APIs to find out whether it's vulnerable. Any and all of those various types of scenarios are visually represented. And I should also emphasize that you can click into, pretty much any of this.
Hey, Dave. Hi, everyone. This is Dan here. I'd love to just add a little bit onto this. You hit it right on the head, right? The application, the visual application flow is really valuable, but equally as valuable is or more maybe even is the data behind it. Like you're saying, understanding the upstream and downstream dependencies of the services and the APIs enables us to do things like track the data flow across your application. Understand typical API call sequences and identify anomalous API behavior from that, and even to do things like test set reduction when we're testing the APIs, because we understand how the flow goes, what the common sequences are, and how the APIs are connected.
Yeah, that's awesome, and I should also emphasize, and that's great. And by the way, welcome, Dan. Great to be hanging out with you today.
Guys,
the team at Traceable is applying intelligence to this, right? So this stuff isn't just being done in a vacuum. What you've got is a group of application security experts that are, behind the scenes continuously adding intelligence into that platform, looking at your particular scenario, your use cases, your queries, your responses, the whole nature of how your application is built. And they're applying that intelligence behind the scenes. And so again, it's tough to show the entire thing in one screenshot, but you can click for days within this interface and really get to extraordinarily finite levels of really interesting information that prove valuable and useful for a number of these different use cases. So absolutely. So moving into this and just showing you a little glimpse of that, here's an example of a service. And as you can see, it's pretty detailed. And again, I just want to emphasize that a number of the areas here are clickable. So you can, sort of dig in to places that look interesting to you. So maybe it's based on latency. Maybe it's based on error conditions that have been observed. Maybe it's based on certain patterns of requests or responses that are being seen within the environment. Maybe, hey, it looks like an anomalous pattern that we're seeing here. We expect the application workflow to be X to Y to Z. Looks like somebody's continuously trying to go straight from X to Z. That's really strange. Why, right? So you can start digging down into some of that. You've got the request, you've got the endpoints, you've got these dependencies, which I thought was huge. And especially coming at this from somebody that's done application development in a former life and works with those teams on a regular basis today, that to me is enormously valuable. I want to see the dependencies of what is related to what and understand where, hey, maybe something's broken. Maybe we've got something that's causing a bunch of latency because we haven't plugged them together or sort of stitched the code together correctly in a way that's needed. That visibility is huge. So I always try to look at this through the lens of more of like an operative or troubleshooting model, just as much so as I would a security model. And I think that quickly and very easily within the context of your application visibility that's been surfaced here, you can easily start to see some of that showing up, right? So again, really a great way to sort of trace down through the high level, go down another level, you can go down more levels, so many levels, but all of them extraordinarily valuable. And what you don't necessarily see here, so I just want to highlight this, and I know don't squint too hard into your screens, but this is the overview screen. And so you can see sort of a mapping over on the right that shows you, some of the sort of the health checks and other things. This is all great. But if I click across this little menu that's under the name of this service, right? In this case, Nginx Trace Shop, I've got endpoints and I can just narrow things down directly to that. If I'm looking, hey, you know what? It's the security team. we really only care about the malicious behaviors. We want to jump straight to the malicious stuff because, well, that's what our purview is. You can do that as well. You can get into specific traces. So just the traces. I want to look at the traces because naturally I'm troubleshooting or I'm trying to figure out what's going on. I can also look at metrics. So, hey, we've been measuring this over the course of a week, 2 weeks, 4 weeks. We want to see what that comparative point looks like for a number of different sort of operational metrics that might be collected here. So you've got different ways to sort of click through here and get this level of visibility very, very easily with, I would say just, no pain involved at all. It was pretty easy to figure out where we were. So moving along, near and dear to my heart, certainly coming at it from a security perspective, is the API risk scoring. So I want to know immediately what that's about, right? I want to get a sense of what these endpoints are and see what those look like. Oh, let me go back real quick. Sorry about that. I want to take a look at this sort of from a, I'll call it a ranking perspective, because that really is something that's reflected here. You can see these risks being scored, as I said, sort of in real time as they're being discovered, as these endpoints are showing up within your discovery framework, they're being scored, because you're looking at what's coming, what's going, sort of in real time. And those scores are being applied. Now, what's cool too is that the scores can fluctuate, right? They can change. This is not static at all. Based on what you're seeing, okay, right now at the very top, this series of GET requests to past orders, pretty high risk, and you can click right into that and see exactly what's going on. And dig down into why is this a high risk? What is actually leading to this? And so I chose to sort of highlight some of this and show you, all right, the breakdown, even just hovering over it, is showing you, okay, hey, wait a minute, we've got a high, ease of resource discovery. It's simple. So the likelihood is affected here. So if I'm looking at this, hey, how's an attacker going to come at me? They can find this resource very, very simply. It's exposed, for example, externally. The exploit surface is readily available. There's no protective controls seemingly in place to, potentially do anything to help us here. And the ease of access. So yeah, the likelihood of an attacker finding this and trying to do some damage is pretty high. The impact, based on some other factors, and we'll get to this here in just a moment, loss of confidentiality. Maybe there's some sensitive data that's being thrown around as part of this application flow. Again, sensitive data exfil could be occurring here. Exposure surface back here again could be showing us that an attacker could easily find this and then cause problems for us by yanking data out of our environment that we probably don't want them to have. So again, really good, very useful information presented quickly to sort of show us exactly what that is. And if you want to see one step beyond that, here's what you can start getting into, right? The detailed risk breakdowns. So that one that we had at the top of the list, of course, it's the highest risk. It's what's showing up at the top. Look, security professionals, we're wired to look at anything that shows up red. So look, I think that's a good thing, right? We're conditioned in such a way. Anything at the top of the list that's red, we're going there first, as we should. And so, of course, I clicked into this one to see what was what. And as you can note here, we've got a broader breakdown of likelihood and impact to give you a sense of what some of the critical factors leading to the risk score were. And if you want to get a deeper breakdown of that, then you can. So hold that thought, because I'm going to show you that here in just 1 second. There's definitely some real detail behind this. So the team at Traceable has really done a good job at helping anybody that wants to know exactly what was used to calculate that risk. You can get that, right? So there's no ambiguity. It's not hidden behind the curtain. Nope, it's all right there in front of you. But this is sort of the snapshot view of it. And here you can also see what's known as the API DNA, which is showing us, essentially all the values, all the, components that are a part or an element of the API itself. So it's not just some sort of big categorical API, imagine air quotes here. It's actually showing you what behind the scenes is being, sort of sent back and forth, what the data fields are, what the specific fields involved in that API query or response look like that are naturally leading us to have this score that we're now seeing in front of us. And again, we'll come back to some of this in a minute, because you've got all sorts of cool query abilities here within the interface. And so just to show you the risk scoring breakdown, absolutely lots of detail. And I can even go further within this. And so, just in the interest of time, I won't just keep clicking down, turtles all the way down sort of situation. But you can go and really break this down, and you can even modify some of the scoring. So if, again, if you decide, hey, look, our scoring model, we've got some mitigating factors that we think reduces X, Y, or Z factor for the likelihood or the potential impact, you can modify those things. So I love that. I like having that granularity of subjective risk scoring if I want it or if I need it, based on, let's say, a pre-existing risk analysis or a risk assessment model that you already have. So you can adapt this and sort of put it into your own context. And to me, that's critically valuable for any organization that really spends time evaluating risk and, of course, making sure that the risk is accurate and contextually relevant to their own organization. Good stuff all the way around, right? So now we're moving into sensitive data. And the sensitive data factor, I think, is critical too, because increasingly, that's exactly what applications are handling. Nobody needs me to tell them that. But there's a great capability built right into Traceable to help detect and highlight wherever sensitive data is noted. And so if you go back into the API endpoints and sort of see what's there, you'll see the exposure specific to sensitive data represented in that. And so here's just a quick snippet or example of what that might look like. Here you can see we're going into this, again, past orders, which we just saw a moment ago, that got flagged or highlighted as being potentially high risk in terms of what's being observed. And you'll see some of the vulnerabilities. If you look sort of down towards the left-hand side in the lower left-hand corner, why is this being noted as a higher risk situation? Even if it's not directly under attack at the moment, there are vulnerabilities here, right? In other words, hey, there's nothing preventing somebody from just continuously monitoring or sniffing this. There's no encryption applied. So we have a clear text, potentially monitorable API that is exposed in some way. And naturally that, that leads us to say, all right, well, what could that mean? Especially as we start digging down further into the sensitive data factor of it. But, again, you can see a lot of detail here. Dan, I didn't know if you wanted to say anything about sort of what the specs and what the sort of data captured look like here, just because I know it's a pretty important feature for you guys.
Yeah, so there's actually a few things that I'd like to point out on this screen. One is it's not just sensitive data, as you mentioned. For every API endpoint and every service, we're doing all this discovery, and we're also discovering insights like the user roles. You can see that in the pie chart over there that says this particular API is primarily contacted or connected to by purchasing user role and a bot or two. And so you get that visibility, get level of encryption, like you mentioned, whether it's authenticated or not, and all sorts of other information that we're collecting about every single API endpoint and service. So a lot of data for us to make decisions about whether or not these different endpoints are being used in their normal way, if their behavior is normal or abnormal. And then on the right, as you mentioned, this is you're seeing the Open API specification that is showing you where we're highlighting the sensitive data within that specification. So this specification is auto-generated and constantly updated from runtime traffic. And it's something that can be written out. You see the download button there, so that you can save it to your disk or save it as your API documentation. I think one of the challenges we know is that keeping documentation up to date is always a challenge, but it's pretty important, especially as people use it to develop the next thing, that connects to your different services. And so, and we'll see this a little bit later on, that this documentation comes into play with the new feature that we've just added. So.
Awesome. Yeah, thanks for that, Dan. I know you had some additional context to add. And as I said, I mean, trying to highlight all of these things that are packed into this platform, it's fun to have Dan here to chime in and really give you guys a little bit of additional visibility behind the scenes, because there's just a lot of stuff happening. Just to do a quick highlight of the sensitive data within the API catalog. And again, you can't see all of it here, but they do a really nice job, I think, of labeling this. So you can see the different data types that are represented across all of the different endpoints and things that are shown. And if, again, if you sort of squint into your screen, you don't have to necessarily, right? But you can see, number one, the top 10 observed data sets. So you can see things like authentication and authorization data. You can see things relative to certain types of data that's been observed. So you can see things like PII, you can see maybe payment card information. You've got a whole bunch of stuff that shows up. And again, this is continuously updated and maintained and tracked. I think it's really important, this, even though it shows up in this little summary tab, to show you the cumulative number of API endpoints with sensitive data types. I don't think a lot of organizations fully realize just how much sensitive data is not only externally relevant and sort of showing up, but also internally in certain ways that they might not understand. So seeing those numbers is sometimes an eye-opener, and it might lead you to sort of embark upon a deeper analysis of where that data is, where the sensitive data could be potentially exposed, and maybe obviously look at things you could do to mitigate that if it's possible, right? So I think that's important. And you get a quick risk breakdown. You've got these very specific data types, and you can break down the endpoints as well below this and see how they're labeled. And they're sort of color coded based on specific types of data that have been seen. So it's really easy to figure this out. I think this is a nice snapshot that, as always, you can dig down into even further to get better information on which endpoints are sharing what, where they're actually, sort of linked into different types of services, how many domains they might be associated with, and of course, whether relevant in, internal scenarios, whether it's cloud-based, et cetera, et cetera. So here, of course, for the security people that are hanging out here with us today, this naturally is something where, maybe, it depends on the circumstances, of course, you're going to want to go and investigate maybe something that, maybe you're tying this into some other observed behaviors within your environment. Hey, we think we saw some really strange activity around this application infrastructure. We want to go tie it together. We want to start finding out, maybe where those API endpoints are showing up, where the sensitive data is. In other words, has an attacker already found us? Have they been able to exfiltrate anything? What can we do? So we went and chose one. We chose some credit card data to start seeing where this information was. And again, maybe this is a case where we're concerned about compliance ramifications. We've got auditors breathing down our neck, and they're coming in next week, and oh my gosh, we're potentially exposing something that we shouldn't be exposing whatsoever. And so we clicked into the credit card details and say, okay, where is this stuff potentially exposed? And as you can see, as Dan just highlighted just a moment ago, you've got this breakdown of information that can be saved, can be exported out. So if you want to have some record of this and you want to go take it back and say, hey, let's work with the developers and figure this out, okay, there you go. But you can see, where it was, created, where it was last updated. And as Dan mentioned just a moment ago, the different user roles that are coming into this. So you can see it's most often being requested by purchasing. You've also got some generic requests coming in, and you can dig down into any and all of the various facets of this particular API endpoint to find out, hey, what exactly is going on? But what's great, and what we found was really useful, is that the Traceable platform highlights it for you. So you don't have to go digging, right? You go and click down into the relevant area within the platform's interface, but it's going to show you and highlight for you exactly where that credit card CVC number is in fact showing up within the entirety of that API interaction. So you don't have to guess at it, which makes it hugely valuable, especially at scale. If you've got a lot of data flying all over the place, being able to get there quickly and readily and say, okay, look, this is where it was seen. What can we do about protecting this? That to me is the real power of this. It just sort of brings it straight up to you. Now, the API DNA, which you've seen reflected here, right? We've sort of been talking about it, and it's been in a number of these different screenshots and things represented. It's all about those parameters, but as I mentioned just a moment ago, you've got a broad array of filtering that you can do. And I think this is where, just speaking for somebody, thinking ahead, thinking about what a day-to-day usage scenario might look like for me or for a number of other stakeholders, I'd say, okay, look, I want to find out, I just want to see the stuff that's exposing sensitive data, or I just want to see APIs that are behaving, maybe in a specific way. I want to go be able to selectively dig into parameters across, who knows what other whatever number of APIs I want to see are showing me this type of sensitive data. So taking the example we just finished up with some investigation and some queries, right? We just went and said, hey, let's go see this one example, this one endpoint, and see where it's reflecting, credit card CVC. information, but now I want to go see all of them, right? I want to go dig in and find out what, if any, parameters across maybe the entire spectrum of APIs that have been visible and discovered. Where are we potentially exposing stuff there too? And so here you can see, right, within the API DNA, we can now go and say, okay, I can go dig a little bit deeper. I can go find out additional information. I can start seeing sensitive data represented in, cookie variables or in any number of other, sort of associative data transport mechanisms that are part of this API or this set of APIs within the application. So I guess maybe a different way to put this, you have a fair number of different places that you can go and to do different types of queries to get different information sets related to, sort of what's happening in the environment, what's being observed. And again, you can't see all of the details here, but it's the requests and the responses. So you can see exactly what's happening, not only as the queries are coming in to the API, but also how it's responding and whether or not there's a potential vulnerability that might be there. So I'm going to hand this over to Dan to explain some of the newer features that the Traceable platform's got available now.
Great, thanks, Dave. Yeah, I mean, with all of that data, one might ask, well, how am I supposed to stay on top of all these changes, right? So before I dive into that, it just as Dave mentioned, some of these are new capabilities that we've introduced into the product since the review happened. And then there are also, as Dave mentioned, a lot of depth and parts of this product, so they weren't all covered. So I'm going to touch on some of those as we hit the end of each section. This being the API catalog section. And so I spoke a few slides ago about the OAS, the open API specs, and how you can make documentation out of those. Well, those can also be fed back into the system for the API conformance analysis. And that can also be an upload of developer API docs as well. And what the system will do is look at those and compare it to the runtime information, the runtime spec, and then tell you, where you have shadow endpoints, the endpoints that are live in runtime but aren't showing up in your docs, orphaned endpoints, the opposite of that, where there are endpoints that show up in both the docs and the runtime, but there's maybe a parameter mismatch or missing parameter or a parameter that's there that's not documented, and so you get a really, really good depth view of what you actually have running in runtime versus what your documentation tells you have running in runtime. And this, of course, can be scheduled or done on demand. Next slide, please. Another piece that Dave pointed out when we were looking at the overview for the API endpoint is vulnerabilities. So that was showing the vulnerabilities for that specific API endpoint. You can also go and look at it from another perspective, which is across my system, across all of my applications, all of my services, what are my vulnerabilities, and then look at them from the perspective of, okay, if I have, for example, a lack of encryption, and I want to see which endpoints have that problem, then it's very easy to do that and to identify those endpoints and to take action on them, to either open a JIRA or a ticket to get those resolved where all the data will be pulled into that, or to track them right in the system. On the right side there, you can see that we have tracking for that, so that those can be remediated. Next slide. And then kind of rolling this all up, everything that we just saw around security posture, API security posture, is the API security posture dashboard. This is fairly newly introduced as well. This is your daily API security operations dashboard, can be. It shows you the top 10 risky APIs, the sensitive data overview that we saw in a more detailed screen. It gives you knowledge, like, for example, which APIs are handling data and don't have authentication, right? Something that we don't want to have happen. Gives you a summary of the conformance analysis on the right side, so you can see where your shadow APIs are, especially the ones that have sensitive data in them. Yikes. And a good overview, and the key here is it's one click away from getting down into the details so that you can dig deeper and get more clarity on the situation. So those are some new things around the API catalog or discovery issue capabilities that we have that I wanted to kind of point out. Back to you, Dave.
Awesome. Yeah, thanks, Dan. And again, it's always valuable. And it was funny working with the Traceable team, right? There's so much changing and happening there. Unfortunately, these reviews are a bit point in time, as Dan kind of stated, but these are important features that we felt, hey, it's a good idea to go ahead and surface them and make sure everybody's aware of them as well. So as Dan sort of mentioned, that was the end of the first, quote unquote, section of the platform. And the next one that we're going to be touching on is the API protection section. And naturally, it's great to know what's going wrong or know what's going on, but having some tools at your disposal to actually remediate things or to address some of the potential threats that you're facing, I think is just as valuable, of course. And so the good thing is Traceable has some of those, and so we were easily able to go and do some queries and again, dig into things so that we can perform some investigations. So we've got this events section that includes a number of different types of filters, and I'll just sort of highlight that here. You can see very quickly the things that are getting flagged. In other words, hey, what are the events that are worthy of note for a security-oriented organization to go and follow up on? And so there's a bunch of these different attacks. And, again, I'm not really doing it any justice with this sort of admittedly shorthand list that you see here. But, the OWASP web and API top 10s all reflected. And a lot of people build their threat modeling and such around those. So naturally, that's a good starting point. But I think it's gone so far beyond that in the application sphere that you have to address things like business logic attacks. Again, people trying to go from X to Z versus X to Y, which is the expected user use case workflows, abuse of those APIs. So you see some obvious attempts at fuzzing or sending in some really odd data to manipulate the functionality of the API from what it was intended to be. Fraud, right? So fraud where we're trying to, perhaps spoof identities or mask identities in certain ways to hijack accounts or take over sessions or do things unusual like that. Naturally, those are going to be reflected as well, and on and on and on, right? Unusual patterns of behavior. But I just want to emphasize here that this is all fueled by and informed by the team at Traceable, who have an enormous amount of depth in this stuff. So there's a bunch of intelligence operating at scale behind the scenes across and layered in to all of those queries and responses that are observed. And so again, it's not a point in time analysis, right? The OWASP web and API top 10 might be something that's fairly well known and somewhat static on a year-to-year basis, but the nature of how those attempts and exploit sorts of scenarios are playing out might be changing depending on the application types, the API types in question. And so just digging a little deeper, you've got the ability to dig down in and really see exactly what that API protection capability could give you and really get a whole lot more detail. But I'll tell you what, I'll hand this over to Dan. Dan, you want to just sort of elaborate on all these different pieces that are shown here?
Yeah, sure. Thanks, Dave. Yeah, so this is what you're looking at are the details of a specific security event. In this case, this is a BOLA attack. BOLA, for those that aren't aware or familiar, is a broken object level authorization. So this is when a attacker is authenticated, but they get access through a bad designed API that gives them something they're not authorized to see, an object in particular. And so this is actually one of the top vulnerabilities in the OWASP top 10 API vulnerability list. In the orange area on the top is the description of why the ML system flagged the event. If you look closely, squinting, you can see that there's a parameter 2, that doesn't match the typical parameter user behavior. And there's, of course, a lot more complexity below that, but in the interest of time, I won't get into that here. There's general details, attributes of the communication of the transaction, details like the endpoint that was attacked, the status code that was returned, the threat actor, which we'll talk about more in a minute, who caused the event. And then, as Dave mentioned, complete headers and bodies of both the requests and the response. We do have the ability to redact or obfuscate sensitive information so that it is protected and work off the metadata. And then right now, if you look at the body, you might be sitting here saying, well, wait a minute, it's empty, right? So unfortunately in Ebola, you don't end up picking a lot of interesting data in the attack packet from that perspective. But above it is what we call the user API flow. This is every API call that the attacker made on the way to the attack point in red. This is the API kill chain, right? And this provides a great amount of context, which helps with forensics, discovering collateral damage, digging in, and even doing remediation. And you can dig into that from this screen here as well.
Awesome. Yeah. And to Dan's point, it's impossible to do it all justice because there is an enormous amount of detail that you can dig down into. But even beyond that, I mean, there's so many different things that Traceable offers in terms of not only detecting stuff, but sort of following up on it and tracking and creating even correlation cases within the platform itself that I think it warrants mention here. You can actually create some blocking mechanisms. You can find definitive proof, for example, of an attacker or an actor that's using very similar types of methods or TTPs or things, maybe from even different IP addresses or originating from different geographic locations, maybe even looking at correlated activities across various timelines that are showing some representative sort of similarities or things that say, oh, okay, even though it's coming from somewhere else, it's pretty clear this is the same attacker. They're doing exactly the same thing in exactly the same way. And the Traceable platform brings all that together. You've got a whole bunch of different dashboards and such within the API protection category. Some of the other ones include APIs under threat, those that are maybe actively being attacked as we see this, or just overall generic threat activity that shows sort of a bigger breakdown to help you see what you want to see depending on the circumstances. And again, here's a quick example where we can go in and say, okay, we've got some user, right? So somebody's trying to log in, they're using this particular email address as their authentication mechanism at this particular moment in time. And of course, naturally, the Traceable team made it easy to spot here. hacker@darkweb.com. Yes, okay, definitely a legitimate user. But you can explicitly deny them. You can do a whole bunch of other things around a specific actor within the platform too. So let me actually just chime in a little bit here, or flip it over to Dan, because I know he has some additional context for you.
Yeah, thanks. Yeah, hacker. This is a dark web is our attacker with a lot of bravado, right? So, yeah. So if I could qualify on this a little bit, a couple of things. Traceable has put a lot of effort into uniquely being able to identify users and tracking their activity, as you said, across IP addresses, session resets, token changes across time. And we do that by digging in to the transaction packets. With modern apps, it's not trivial to identify a user's identity separate from their client, consistently across transactions, unless you can connect and analyze all the associated transactions to understand the business logic of the app and therefore find the user and track them. And so like with an XDR system, what we're looking at here is a threat actor storyline, right? This is everything this user has done to this app over time, all of their attack attempts. And as you pointed out, Dave, with every attack attempt they make, the system increases their threat score accordingly. And we can flag or even auto block threat actors that have passed a defined threshold. And then when we block them, it's specifically them out of the application, no matter what else they're going to try. So that's one way we can do blocking is the user, the bad actor, holistically. We can also do it at a vulnerability or attack level, and other ways as well, but we'll get to that. So.
Awesome. Yeah. So moving into, again, the ability to create specific types of rules, you can basically tune this. So it's not entirely based on just exactly what the Traceable team says, hey, this is what's good for you. And of course, there's a lot to be liked there. But you can tune some of these detection capabilities and your protection controls yourselves as well. So I think this is huge, especially for teams that really want to get down into the guts of this and really want to make sure that they've got very particular and highly, highly specific detection rules and even exclusions where you say, oh, yep, this is just something that's getting flagged because, yes, admittedly, it is a little bit odd, but it's normal. For our particular scenario, it's normal, and we just don't want to be alerted and sort of following up on it all the time. I think that's important. You can use a number of different criteria to actually influence this. So good examples, of course, would be geographic scenarios, locations, IP addresses that things are coming from. You can use custom signatures with pattern matches if you want to get into those. And so here's just, again, a very simple snippet. We went and created the SANS test custom event detection rule, where we came down and said, oh, okay, I want to see a very particular element within the headers, right? I want to see SANS test or something within that. And you can go, obviously far beyond that, as much so as you would like to, but you have the ability to come in and do just pretty much whatever you want to get, sort of custom rules in place. And I always look at this from a security operations standpoint and say, the more customized I can get, doesn't mean I'm always going to want to, but the more customized I can get, the better, because it's going to help kind of cut down on things like false positives that waste time, right? And that's really the name of the game in security monitoring and operations today. So Dan, back over to you. Let's hear about some of the new stuff in this category.
Yeah, that's a great segue. Thank you. Yeah, absolutely. So first thing, we do have policy-based detection and blocking. So as you mentioned, Dave, custom rules are not required, but they certainly are valuable to be able to make sure that you're getting exactly what you want to detect and block. The ability to customize API detections we're finding is especially useful for our customers who are migrating from their legacy WAFs, but they want to keep those custom rules that they're, continue using them until they're comfortable that, they've made the transition cleanly. And it's also, as you mentioned, great for being able to make sure that those edge cases get covered. Traceable, however, does come with detection and blocking policies. That's what's showing here. This is in the admin kind of interface where you can set your policy. And they're built in. You don't need to maintain them, but you can turn them off and on to tune the ML. And this is what differs from Traceable to, in this area from a WAF, for example. Yeah, they have rules, we have rules. But the difference is these policies are for threat validation only. So what that means is our ML is always watching and checking for anomalies. And when those anomalies get identified, then we're looking at the turned on rules here, policies to identify what is actually a problem. So we're removing a lot of the noise first, and this results in very low false positives. Next one. Thanks. So another new piece that we've got is data protection. So this was released shortly after the review. We saw how we can track sensitive data in many different places throughout the UI. Traceable is watching and knows your sensitive data groups and types and where they're showing up. Data protection identifies where that data is actually being exfiltrated, where it's actually getting pulled out of your system and in the hands of the wrong people. So you can quickly respond that way to shutting down the data loss. We can see who the users are that are exfiltrating the data, which API endpoints are the ones that are leaking the data, which services are involved. It can be sorted in many different ways. There's a live view plus a historical view. So you can look at what's happening right now and then take action. And as well, on the right side, the little black box, if you can squint really hard, is assessing the risk level of this particular event, how much data is getting out there, what type, who's getting it, like is it multiple locations, what's the geography, et cetera, so that you can prioritize the mitigation. Next slide. And then rolling this all up is a threat activity dashboard. We started by looking at the events, and that can get noisy. So we have a few different ways where that information gets rolled up so that we can have focus on the things that matter. It's a fairly new operational dashboard. As Dave mentioned earlier, for API protection, we have threat actors, APIs under threat, and this dashboard now. The threat actors are the roll-up of the users that are causing problems. APIs under threat are clearly exactly what it says, the APIs that are at this moment getting attacked pretty hard. And this dashboard, which rolls up things like malicious activities and sources, API abuse that we're seeing, the top threat types, which can also be sorted or shown by the list that they belong, whether they're a CWE or a an OWASP top 10 or an OWASP API top 10. And then this is kind of like a double, as Dave's mentioning. It's kind of hard to show like a lot of the depth here, but the left graph is the base. But when you click into any of the threat types, then you get this right half of what you're seeing, and that's giving you things like the top threat actors. We can see on the top right, there's several threat actors for this particular threat that's happening, and they're all rated critical. And then we have an event timeline with the circles there telling us how much the attack's happening, when it's happening, and those events below are all the similar events, and you can click into any of those and then get direct access to the event details, so like we saw earlier. So you can start at an overview, a high level, and drill down deep pretty quickly into the details where you can investigate and work towards remediation or mitigation. Back to you, Dave.
All right. Yeah. So to sort of wrap up with the final sort of category, essentially there's a whole analytics section within the platform that allows you to sort of gain insight over time, because obviously there's a lot of observation going on and there's a lot of detection scenarios that are going on, but it's not just today, it's not just yesterday, it's over weeks, it's over months, it's over periods of time. And what that can help you to do is really figure out, hey, what are sort of the trends, if you want to think about it that way. What are some of the things that we're seeing sort of at a deeper and broader level over periods of time that can alert us to the fact that, hey, it's not just an attacker showing up yesterday and throwing a bunch of crazy stuff at an API. It's repeated low and slow attempts that have been observed over time as a pattern to help us detect things like long-standing or ongoing fraud attempts and so on. And the reason I look at this is really, really valuable. I think there's a lot of merit to say, hey, look, as an app team or as a DevOps team, I'm going to gain a lot of this because I'm going to see, hey, these are things that we could do to improve, some of the maybe less obvious things that are coming at us. But I think as a security team, especially if you've had an incident, God forbid, and you're having to do a postmortem, or even if you just come under fire, right? There's an attack that's ongoing, you're having to respond to it. You're going to want to go back and say, okay, what could we have done to perhaps prevent the attack in the first place, or maybe to just be able to respond more effectively when those kinds of things do occur. You can get that level of detail in the analytics section of Traceable. And so this is just showing you a quick breakdown of some of the attack activity, but you'll note those little plus signs over to the left. And anytime you see one of those little plus sign, it says, yep, there's a heck of a lot more detail. In fact, you can just see, again, the squinting into these screenshots. There is a plus 326 hide, which is giving you a glimpse into just how much is being rolled up. What you can see is this, authorization bypass attempt coming in for this particular query to an API endpoint. And you can say, okay, well, that's great. I can obviously say that somebody's trying to do this, but I need to get down into the guts of it. I need to go and find all of the varied attempts that are representative to that category of attack activity. And I can do exactly that. So I can click my way, frankly, as sort of far down as I really want to or need to go, and get a heck of a lot more information very, very quickly. And Dan, I know you've got some thoughts on this too, just some things that you might want to add, because as I said, screenshots are tough to just show you the full picture.
Yeah, for sure. Thanks. Yeah, so this is showing every API call of the attack transaction. So across services and systems, what the observability community calls a trace. And this is useful for seeing the big picture context of the whole attack. And you can, of course, dig deeper into the theme, right? You can dig deeper into each of the spans, each of the rows, and go get the API call details. So really great place to start and see the overall context and figure out what else is involved and then dig in. And I think, Dave, your next few slides are actually going to show those call details, right?
Yep, absolutely. So you can see, as Dan just highlighted, I should really say whatever it is you want to see, whatever it is you need to see. But if I'm trying to create highly tuned and highly scaled, say, detection rules in even external services, right? So let's say I'm using, web app firewalls or other types of detection platforms, within my environment, I need all the real sort of guts of the request and what that looks like that's been flagged by Traceable, and I can get that. So what you can see here, of course, is the query that came in, and you can see all of the different variables. You can see the specific elements of how that variable is constructed. And the more clear that is, and the more granular it is, the better able I am as a security operations person to be able to go create something that matches up to it and allows me to highlight it maybe at different places within my environment as well. So I think there's a lot of deep insight that's coming out of this, right? I can get that attack detail and bring it up. And I can also use Trace Explorer to go query against this. So I can go down to the trace and say, okay, look, not only do I want to just see the attributes there, but I want to go to the actual attack and the trace of that attack and see the user that came in, how they requested it, what the time frame was, get all the details. And you can see down in the lower right-hand side, the body of the request and how it's being issued. And so you get that sort of insight. It's almost like a recorder, is how I came to think of it. Traceable is basically recording this to give you not necessarily like a playback model, but the ability to go back and say, okay, this thing happened, an hour ago or 6 hours ago or 12 hours ago. I wasn't right in front of it when it happened, but I'm coming back in and I'm saying, all right, what did it look like? What can I learn from it? And you can do that at scale over time. So you can see too that some of these different types of sort of filters have been applied, right? The specific session, the specific aspect of the API endpoint, PII equals true. It's all very controllable. So you have a lot of flexibility in where you go and how you get down into those traces, again, to get pretty much any of the detail that you want. So just to finish up this category, Dan, finish us up.
Great, thanks. Yeah, and this one is actually almost an entire new category. This is another just released capability I'd like to show you all is API security testing, because it's one thing to know what you have and then to be able to protect them and to do analytics on them. But we also, of course, want to make sure that we don't have those vulnerabilities in the first place. And we think we bring a lot to the table there with all of the visibility and data that we have. So we call this XAST currently because it's beyond DAST and IAST, two different security testing methodologies. And it focuses on APIs. It's designed to run API tests out of your CI/CD pipeline, whether you're using Jenkins or Circle CI or Harness or GitHub, GitLab. And it's the idea, of course, as we all are familiar with push left, is let's catch those vulnerabilities as early as we can so that we don't end up having to deal with them once they're in production and they actually cause a real breach. XAST uses previous API sequences and payloads to perform dynamically generated tests that are relevant specifically to the vulnerabilities and APIs that you're testing for. So that's where, as I mentioned earlier, the ability to track and understand and trace all of the communications and understand how the API sequences get called allows us to understand, if somebody is making a change to particular, API, A, then we all understand the downstream, upstream, and downstream APIs and services that are going to get called from that likely. So we want to test those as well. So we use the API behavior of upstream, downstream to do test set reduction so that we're not having to test everything all the time because we can actually optimize. And then this also can be done manually. You can go in and define a set of tests and say, hey, I want to test, just encryption or just authentication vulnerabilities. If you go to the next slide. It's actually mostly the same, except now what we're looking at is that with the tests, when you get a result, each vulnerability found is presented with rich information about the test transaction, what was used as a payload, what was the communication, what was the communication path, what is the vulnerability details. As you can see on the left side there, where we have like the CVSS rating and lots of information about the vulnerability itself, including mitigation and remediation information, because most developers are not security experts and most security experts are not developers. So we need to help each other out here. And then the ability to quickly create a ticket or a task by sending it out to Jira or ServiceNow, or whatever your favorite tracking system is, so that you can capture all these details or get a link back to this and help along the remediation process. And one more, please. Thanks. And then, of course, you can also customize and download reports because we need to be able to share and store the results of each test run to keep everybody informed and auditability as well. So this is just a very short little introduction to what we just added with the API security testing. We actually just yesterday did a deep dive webinar on this new capability. So if you're interested to learn more about that, this particular piece, check out the Traceable website for access to that recording. I'll pass it back to you, Dave.
All right, and since we're pretty much out of time here, we had a lot to present, so I'm actually feeling pretty good that we got through it all within this time. But I'll just give my final thought. Obviously, there was a lot to like in the Traceable system. For me, it was just the comprehensiveness and all the capabilities that were there. I was a little jealous when I saw some of the new things that Dan and the team have come out with since I had the opportunity to do the review, since they look pretty awesome as well. But just looking at this from the big picture standpoint, I think any organization could benefit from that level of visibility, as well as some of the protective capabilities, all the details about the attacks and the traces there, getting those risk scores and certainly getting the analytics capability over time. Just a huge amount of really valuable assets and information that, again, I think would be really, really helpful to organizations and their development teams. So I'm going to go ahead and just move us directly to our acknowledgements. Again, thanks, Dan, so much for being here with us today. And Mary Lynn, I will pass it directly back to you.
Thank you so much, Dave and Dan, for your great presentation, and to Traceable for sponsoring this webcast, which helps to bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.